This historical photograph shows a busy market where merchants track inventory. You often know the type of goods needed long before knowing the exact quantities. When you look at this stall, the physical volume of the fruit is clear, but the exact number of bananas is hidden from you. In mathematics, we use a placeholder, usually a letter like X or Y, to represent those unknown amounts. This is algebra. Think of a variable like this box. A specific number is hidden inside, so we call it X. If you have 3 boxes, you write 3 times X. In algebra, we drop the multiplication sign and simply write 3X. Using letters for missing numbers allows a business owner to calculate total costs, or a scientist to map out a disease, even while some of the data is still being gathered. This shows 3 matokes and 2 pineapples. In algebra, you only add or subtract items in the same family, called like terms. Add 1 more matoke and we group it with the others. 3m plus 1m is 4m. The pineapples stay separate. A term sign is permanent. Here, we circle the y terms, locking in the minus sign, and the x terms with their plus signs. Sliding matching variables together. 4x plus 2x is 6x, and 3y minus 1y leaves 2y. Simplifying expressions acts as a necessary filter. It cleans up messy, complex data so you have a clear starting point before you attempt to solve the actual problem. An equation is like a balanced scale. X plus 6 equals 14. Removing the 6 kilogram weight to isolate x tips the scale right. To restore balance, we do the same operation on the other side, subtracting 6. It balances again, revealing x equals 8. We add the triangle's 3 sides to form an equation equaling 26. Grouping like terms, 2x plus x is 3x, and 5 plus 3 is 8. Subtracting 8 from both sides leaves 3x equals 18. Finally, dividing by 3 reveals x is 6. By translating physical boundaries into a balanced algebraic equation, engineers and designers can work backward to find exact dimensions from only partial information. Now let's apply these steps to a multi-step word problem. We'll translate a series of English instructions into a single mathematical equation. Look at how this diagram builds. Yusuf takes an unknown number, b, and adds 6. He then multiplies that entire sum by 4. Notice the brackets. They tell us that the 4 must be distributed to both the b and the 6. Finally, he subtracts twice his original number and sets the final outcome to exactly 32. We start by expanding the brackets, multiplying 4 by b and 4 by 6. That gives us 4b plus 24 minus 2b equals 32. By grouping our b terms together, the left side simplifies to 2b plus 24. Now we balance the scale. We subtract 24 from both sides, leaving 2b equals 8. Dividing both sides by 2, we find that Yusuf's original number, b, is 4. You now have the core tenets: use letters for the unknown, group only like families, and maintain perfect balance across the equal sign. Algebra provides a reliable, step-by-step framework to determine unknown quantities and solve problems in the real world.